Good evening to all of you. Am I audible? Am I audible? Please.
Yes, sir.
Whatever the screen. Are you able to see?
Yes, sir.
Okay, okay. Linear algebra. Okay. Linear algebra. Okay. Okay. We are in linear algebra. Let me start. A brief review. First, I started with the definition of matrix. A rectangular array is matrix. Now, the types of matrices. Row matrix means it contains only one row. Column matrix means it contains only one column. Horizontal means here m is less than n, where m is the number of rows, n is the number of columns. Vertical matrix, it looks vertical, m greater than n. If m equal n, we call it as square matrix of order n. Instead of saying n cross n, we simply say order n square matrix. Trace means sum of diagonal elements. Next, depends on elements. If all these elements are 0, we call triangular. If all these are elements are, we call triangular. In particular, it is lower triangular matrix. It is upper triangular. Any one of these we call triangular. Now it is a diagonal matrix. It is both lower and upper triangular matrix. If the element along diagonal remains same, we call scalar matrix. If this is 1, we call unit matrix. These 4 are square matrices. If these are also 0, we call zero matrix. The zero matrix or null matrix can be rectangular also. Next. Now observe here, triangular, diagonal, scalar, unit, all these should be square matrices. Never say a rectangular is triangular, please. I'm repeating, never say a rectangular is triangular. Because we are going to discuss rank topic today. We are using this. Next one, depends on operations. A transpose. Using operation A transpose equal A, then A is called symmetric. If A transpose equal minus A is called skew symmetric. If A transpose equal A inverse, we call orthogonal. Or it is same as A into A transpose is I equal A transpose into A. Similarly, conjugate of a matrix. Replacing I with minus I, you will get conjugate of the matrix. If the entries of A are real numbers, then A bar equal A. Conjugate transpose. Conjugate and then transpose. If conjugate transpose is itself A power theta equal A, we call Hermitian matrix. A power theta equal minus A, skew Hermitian. A power theta equal A inverse, we call unitary matrix. The diagonals of Hermitian are real numbers, means they lie on real axis. The diagonals of skew Hermitian are pure imaginary or zeros, means I times. A power theta equal A inverse, unitary matrix. It is same as the product of A and A power theta is I in either order. Suppose these two are equal, may not be I, we call normal matrix. A square equal to I, then A is called involuntary matrix. A square equal to A into A is A, idempotent matrix. A power k plus 1 equal A, then A is called periodic matrix with the least positive value of k is called period. A power k equal to 0, the least positive value of k is called index. Here A is called nilpotent matrix. Every real symmetric is Hermitian, real skew symmetric is skew Hermitian, real orthogonal is unitary. If A is Hermitian, then IA is skew Hermitian. Next, determinant properties. AD minus BC is called determinant of the matrix. Third order determinant, you can find determinant of the matrix using any row or any column. Next, fourth order, similarly we express the number of terms in the expansion of determinant is factorial n, where n is the order of the given matrix. The next, minors. Minors means the determinant of submatrices. Here I have taken second order minors of order 3 matrix. Minus 1 for I plus j into mij gives the cofactors. These minors and cofactors are numbers. If you arrange the numbers, when you replace these with their cofactors, we call cofactor matrix. Its transpose is called adjoint of the matrix. Then A into adjoint A is same as adjoint A into A. It is det A into In, which is a diagonal matrix. If det A is 0, we call singular matrix. Det A not equal to 0, non-singular matrix. Whenever det A not equal to 0, you can define inverse of a matrix. A inverse is nothing but adjoint A by det A, obtained from this theorem. Next, A and A transpose have same determinant. When you interchange, you will get minus sign. Same parallel lines, then the determinant is 0. You can take K common from any row or column. If a line means a row or column is sum of two elements, you can write it as sum of two determinants. And any determinant you can express like this. Any row or column can be written as that plus K times the next plus L times the next. Det of K is K power n into det A, because we take K common from each row. So det of AB is det A into det B, that is same as det B into det A, that is det of BA. I have not explained in my previous class. This is adjoint of AB is adjoint B into adjoint A. Please, these are the matrices. Adjoint of AB is adjoint B into adjoint A. Determinant of adjoint A is det A power n minus 1. Next, equality of matrices, addition of matrices, subtraction of matrices, scalar multiplication of matrices, multiplication of matrices. I explained why multiplication is defined row column wise. AB equal to C. Ci is a m cross b, m cross n, n cross b, then m cross b. Here Cij is sigma k equal to 1 to n a I k b k j. Next, the properties of matrices. Matrices addition follow commutative. Matrices multiplication is not commutative. Matrices addition is associative. Multiplication of matrices is also associative. Let's distribute it, left distributed, right distributed. We don't have the notation A by B in matrices because lack of commutativeness. We are unable to use the notation A by B in matrices. Now, A cube is A square into A or A into A square. Both remain same answer because of associativity. We are able to define powers of a matrix. Next, the properties: transpose, conjugate, conjugate transpose, inverse, repeated operation, scalar multiplication, addition of matrices, but here they are not equal. Now, transpose of product here. It is a reversal law except this. Conjugate maintains same order, remaining are reversal law. Next, AB equal to AC implies B equal to C in numbers, but it may fail. AB equal to AC implies B equal to C may fail. Whenever det A is 0, definitely it fails. Product of two matrices is 0 means at least one matrix 0 may fail. Product of two numbers is 0, at least one number is 0. But here, because of row column wise, product of two non-zero can be 0 matrix. Product of two non-zero matrix can be 0 matrix. Similarly, A plus B whole square is A square plus 2AB plus B square is wrong because AB, BA may differ here. AB are met. Similarly, A plus B and A minus B is A square minus AB plus BF minus B square because AB, BA need not cancel. Every square matrix can be written as a symmetric plus Q symmetric. Here A plus A transpose by 2 is symmetric part of A. A minus A transpose by 2 is Q symmetric part of. Similarly, every square matrix can be written as Hermitian plus Q Hermitian. A plus A power theta by 2 is Hermitian part of A. A minus A power theta by 2 is skew Hermitian part of A. Later I explained certain problems. I explained the determinant problems also yesterday. Later I explained the top-down method of finding inverse of a matrix using elementary transformations. Okay, elementary transformation. Interchange of rows, Rij, multiplication of a row by a non-zero constant, Kri, addition of a row to a constant multiple of another row, Ri plus Krj. Similarly, for columns operations. Of course, we use all these operations to find rank of a matrix. Rank won't affect when you use these operations. Now, coming to determinant, you should not use Rij, Kri. If you want to use Rij, you should write minus of it. If you want to write Kri, you have to write 1 by K there. Okay. Now, here, you can use Ri plus Krj or Ci plus Kcj to find determinants. Next, to solve system of equations, you should use only row operations, not the column operations. To find rank, you can use all these operations, rows or column operations. Later, Elementary matrix. A matrix obtained from unit matrix by single transformation. A matrix obtained from unit matrix by single transformation is called elementary matrix. Now, elementary row transformation of a matrix can be obtained by pre-multiplying the corresponding elementary matrix. Similarly, elementary column transformation obtained by post-multiplying A by the corresponding elementary matrix. Using this, Gauss-Jordan developed a method of finding inverse of a matrix. That method is this one. Select the row operations on A successively. Select the row operations on A successively to get I. This A becomes I. The same row operations apply on I. The result yields A inverse. This I explained to the problem solves. Sometimes it is impossible to convert this to I. Means inverse does not exist. Definitely you will get 1 0 row or 0 column. Okay. Whenever the given matrix contains more number of zeros, this method becomes very easy to you to find inverse of a matrix rather than A into A inverse is A inverse equal to adjoint A by delta. You are asked inverse of a matrix. Don't apply the definition or Gauss-Jordan method. You can check the options also using elimination process. Okay, up to that I explained. Okay, now the next. Now, coming to today's lecture. Okay, rank, the concept of rank. Okay, please. To get good rank in examination, you should be thorough with the rank topic. Okay. First, the definition. First, you should know the concept of rank. The rank of a matrix is the order of the largest non-vanishing minor of the matrix. It is the definition of rank. You should know the definition also. The rank of a matrix is the order of the largest non-vanishing minor of the matrix. Let me explain this with an example. Okay, the rank of a zero matrix is 0. If all entries are 0, rank is always 0. Now an example. I have taken a matrix. Okay, rank is defined for any square or rectangular matrix. Please, determinant is defined only for square matrix. Determinant is defined only for square matrix. But rank is defined for any square or rectangular matrix. Now, what is the order of this one? Please tell me. Any one of you, please respond. What is the order of this? Order?
3 by 4, sir.
3 by 4. Very good. Please. Order is 3 by 4. You are telling. We have usual practice of saying 3 by 4. Okay. But the wonder here is by, but you are writing into. I am not writing 3 by 4. I'm writing 3 into 4. Okay. The same thing I explained previously when I'm explaining at New Delhi. One student objected me. Sir, you are writing 3 into 4, but you are reading 3 by 4. He asked me that. Later, I converted myself from the student doubt. It is actually not 3 by 4. It is 3 cross 4. 3 cross 4. It is not into also. Cartesian product. Total 12 elements. Please, okay? I think it is. I got this from a student, in fact, because it is a habit from our teachers. 3 cross 4. Okay. Now, rank. To find rank of this matrix, rank is a number basically. I require minor. Minor means determinant of submatrices. Submatrix means delete certain rows and columns, remaining is submatrix. I require largest non-vanishing minor. What is the largest submatrix? Square submatrix from it, please. What is the largest? Can I take 4 cross 4 from this? Can I take 4 cross 4 from this? Or 3
No,
cross
sir.
3? What is the possible?
3 × 3.
3 cross 3. Therefore, to get 3 cross 3 matrix, I have to take 3 rows but 3 columns. Therefore, I can remove one column. For example, I removed the last column. I selected this. It is a square submatrix. Its determinant I require because non-vanishing minor. Vanishing minor means the minor value is 0. Minor means determinant of submatrix. Here the determinant of this one you can calculate 2 into 24 minus 0 minus 3 into 60 minus 0 plus 4 into 25 plus 8. You can calculate it directly. I am showing the answer directly. I am showing it is 0. I calculated it, it is 0. I require non-vanishing. I can't get 4 cross 4. I can get 3 cross the largest is, but it vanished. So I try to get another third order minor. So I am deleting not the 4th column. I am deleting the 3rd column now. Now it is another submatrix. Now I try to find determinant of this one. These 3 columns, C1, C2 and C4 columns. So I calculate the determinant like it using the definition directly. 2 into minus 2 plus 5. You know how to calculate. Next minus 3 into minus 5 minus of product minus 4. Next plus minus 1 into 25 plus 8. I calculated it. I am showing that to you. I calculated it. It is 0. I calculated it is 0. But I require non-vanishing minor. I require largest to non-vanishing minor I need. So it also vanished. Now I have one more chance. I have one more chance. I can remove the second column. Now take these 3. I calculate the determinant of this one. Again 2 into 0 plus 12 minus 4 into minus 5 minus 4. I simply like it. Okay. I calculated it. The answer here is also 0. It also vanished. I require non-vanishing. So what I do? I have one more possibility. Remove the first column. Now take the determinant. I calculate the determinant of this one. 3 into 0 plus 12 minus 4 into next minus 1 like this. I calculate the determinant. By bad luck, it is also 0. Okay. But I require non-vanishing minor of the matrix. All the minors of order 3 vanish. Order 3. 3 cross 3 means order 3 vanished. Largest non-vanished. 4 cross 4 not there. 3 cross 3 are there, but all vanish. So I should come down to second order. I don't have any more 3 cross 3 submatrices here. Second order. To get second order, I require 2 cross 2 from it. So remove 1 row and 2 columns. For example, I removed the last row, 1 row and 2 columns, please. I remain with this. It is another minor. Minor of order 2 only. Its determinant is called minor, please. Now we calculate this minor value. Minor means determinant of submatrix. It is 4 minus 15 not equal to 0. Non-vanished minor. So observe it. The order of this one is, what is the order of this, please? Non-vanishing minor. Order.
2 cross 2.
Order simply 2. You can say simply 2. Order is 2. Okay, 2 cross 2 means 2. So order of largest non-vanishing minor is called rank. Its order is 2. Hence, the rank of the matrix is 2. We denote with the row of A. Rank of A is 2. It is the definition of rank. So, to find rank of a matrix, we need to evaluate many determinants like this. We come from highest. I require largest. First 4 cross 4 I am unable to get. Therefore, I tried 3 cross 3. Non-vanishing I require, but vanished. vanished. I don't have a third order, all vanished. So I came to second order, which is not equal to 0. Suppose if it is 0, what I do? I will take another 2 cross 2. If it is also 0, I will take another 2 cross 2. If that is also 0, I will take another 2 cross. Like this, till I get non-vanished minor, I proceed. Okay. If all 2 cross 2 are zeros, then I should come down to 1 cross 1, means just 2, 3 like it. Okay. This is the procedure. Suppose in this process, if I get this one 2, 4, minus 1, 5, 0, minus 1, minus 4, 12, minus 1, not equal to 0. I can stop here. The rank is 3 because its order is 3. I can stop the process. By luck, suppose this is not equal to 0. The first one not equal to 0. Immediately, the rank is 3. I can stop here because the largest order of largest non-vanishing minor. Okay. This is the rank definition. Okay. Some others define rank in another way. The same concept, please observe. A number R means here 2. A number R is said to be rank of a matrix. A number R is said to be rank of a matrix if it has at least one minor of non-vanished minor of order R. A number R is said to be rank of a matrix A if it has at least one non-vanished minor of order R. R is called rank, order R. And all minors of order above R. Above R means 3, 4 and so on. Above R should vanish. This is the definition of rank in another way. A number R is said to be rank of a matrix if a number R is said to be rank of a matrix if it has at least one non-vanished minor of order R and all minors of order above R vanished. Above R means R plus 1 minus. When R plus 1 minus vanished, automatically R plus 2, R plus 3 also vanished. Because when R plus 1 all vanished, R plus 2 we express in terms of R plus 1. Hence, when R plus 1 all vanished, automatically R plus 2 also vanished. Okay. Next, it is the definition. We need shortcut methods. Of course, to know shortcut methods, you require definition also. You will realize the importance of definition also when we are doing problems. Okay. Next. Normal forms. IR. IR means unit matrix of order R. IR and 0. 0 matrix. IR and 0. IR and these 3 zeros. If you observe, in one corner, is the top left corner here is unit matrix, remaining are zeros. Suppose you have a matrix of this type. Now, the largest non-vanished minor here is rth order. Hence, the rank of IR is R. Here also, the rank is R because the largest non-vanished. The unit matrix determinant is 1, which is non-vanished. You have rth order non-vanished minor. Hence, its rank is R. Rank of any one of these matrices is R. Next. Echelon form. Observe this. To explain this, okay, I've taken this. A matrix is said to be in echelon form if all the non-zero rows, if any, precede the 0 rows. All the non-zero rows, if any, precede the 0 rows. The number of zeros preceding the first non-zero element in a row is less than that the number of such zeros in the succeeding row. I think you may not follow it. You can easily follow after the examples, please. Okay, I'll explain this through examples. Echelon form. Observe it. I have taken very big matrix here. What is the order of this one? Can anyone please? What is the order? What is the order?
6 cross 6.
6. No. Count the number of rows. What is the order? Order of this one, please. How many rows are there?
5.
5 cross 6.
Very good. 5 cross 6 matrix. Does it triangular? Does it triangular matrix or not, please?
Upper triangular matrix, sir.
No, it is wrong. That's why I explained. I cannot use the word triangular because it is not square matrix, please. It's not square. Triangular matrix is a classification square matrices, but the order is 5 cross 6. It is not triangular. I think you followed. Triangular only in square matrices. You should have diagonal, but you don't have diagonal because 5 cross 6 it here. Okay. Next. If you observe, you have many zeros here. What we do is, observe it. We started here, get down, remaining are zeros, get down, all are zeros. Here also zeros, you can come up to here, get down like this, and then observe this. I have drawn steps in the given problem. If you observe, below the steps all are zeros. Of course, above steps you may find some zeros here and here. But wherever you are getting down, it is non-zero. If this 2 is also 0, we come up above that. This 5, if this 5 is 0, we go like it. This -7 may be 0, already got down. You are getting 2, 5. Next, you are getting this -9. It is not 0. If it is 0, we go like it. Next, this 4. It is not 0. If it is 0, we go like it. Similarly, this 3 is not 0. If it is 0, we go like it. So, if you observe this 3, these corners 4, this 9, -9, 5, and 2 are non-zeros. Non-zeros. Wherever you are getting down, it is non-zero. Okay. Another example I am showing. Please, I am explaining how to draw steps in a given matrix. Now, in it, I can draw like this. All are zeros. If it is non-zero, you can get down. All are zeros. Don't go up. If it is non-zero, I can get down. If it is non-zero, I can go. Below steps all should be zeros. Now, wherever you are getting down, it is non-zero. 3, 1, -2, 8. Non-zeros. Okay, next one. Now, the order of this one is, how many rows you have? 5. 5 cross 4 it is. It is not square matrix. Don't say triangular. Triangular word we use only for square matrices. Of course. Now, coming to this one, you have many zeros here. The order is 4 cross 4. 4 cross 4. Of course, you can use triangular word here. Now, to draw steps, this is also 0. Wherever you are getting down, it should be non-zero. Therefore, I am coming up directly. It is non-zero, I can come like it. Next, it is non-zero, I can come like it. It is non-zero, I can come like it. Okay. Okay. If you observe these steps, we are climbing 3 to 4, here to here, here a flat step, next this one. Similarly, one step. So, if you observe this, you are climbing only one step at a time. You are not climbing 2 steps at a time. If in a given matrix, if you are able to draw steps like this, if you are able to draw steps like this in a given matrix by climbing one step, it is said to be an echelon form. Otherwise, it is not echelon form. Suppose in this problem, here 2, here not 0. For example, it is some 6, 2, 6. I have to get down 2 steps at a time. It is not echelon form. It is not echelon form. Okay. Suppose this is 0, this is 5, and this is some 7. You should get down 2 steps. It is not echelon form. Okay. If you are able to draw steps, getting down one step at a time, then only it is an echelon form. If you get down 2 or more steps at any stage, it is not echelon form. Okay. Now, if you observe this one, now observe the definition. What I explained the definition is, definition of echelon form, I had given in my previous slide. All the zero, the first condition is all the non-zero rows, if any, precede the 0 rows. 0 row means all are zeros in that row. If at least one entry not equal to 0, it is non-zero row. All the non-zero rows precede the 0 rows. Means the 0 row should come at the bottom, the first condition. 0 row should come at the bottom. Coming to the second condition of echelon form definition, the number of zeros preceding the first non-zero element of a row. Preceding the first non-zero element of a row. Number of zeros preceding the first non-zero element of a row. For example, in this matrix, the second row, the first non-zero element is 5. Before it, how many zeros? I have 1 0. Okay. In the next row, the first non-zero element is -9. Before it, how many zeros? 3 zeros. In next row, the first non-zero element is 4. Before it, I have 4 zeros. Similarly, in the next row, before first non-zero element, I have 5 zeros. The second condition of echelon form is the number of zeros, here the number of zeros preceding the first non-zero element increased row by row. Its meaning is that here 1 0, here 3 zeros, here 4 zeros, here 5 zeros. Hence it is echelon form. This number of zeros should increase. Automatically you will get 1 step. If it won't increase, what happens? Here 1 0, here also 1 0. What happens? You are getting 2 steps. It is not echelon form. That's the definition of echelon form. Okay. Now, once if you know the given matrix is in echelon form, it becomes easy to find rank of it. Observe it. The columns here. C1, C2, C3, C4, C5, C6. To find rank of this matrix using definition, I require non-vanished largest non-vanished minor. Means I require submatrix. So I am taking C1, C2. I am not taking C3 because I have not get down. I ignore this C3. Next C4, C5, C6. Please observe. I am taking C1, C2, C1, C2, C, not C3, C4, C5. Now it forms a square matrix. Its determinant is because now it is a triangular matrix. You have 5 rows, 5 columns. Its determinant is 2 into 5 into -9 into 4 into 3. Product of non-zero elements, which is non-zero, not equal to 0. Product of non-zero, which is non-zero. Hence, its rank is order of this. Order means 1, 2, 3, 4, 5. 5 cross 5. Hence, its rank is 5 from the definition. The order of largest non-vanished minor. Whenever steps are given like this, you can easily find rank using this from the definition. But what we do is, we don't do all it using definition. We simply count the number of rows of this. Means first row means this from this 2. Second row from this 5. Third row from this -9. Next 4. That means 2, 5, -9, 4, 3. 2, 5. Next -5, -9, 4, 3. Product means you are simply counting the number of steps. Means number of non-zero rows. Number of non-zero rows. The number of non-zero rows is rank of the matrix. When the matrix is in echelon form. That's why many teachers tell you number of non-zero rows is rank. Number of non-zero rows rank only when the given matrix is in echelon form, please. If the given matrix is in echelon form, then the number of rows is non-zero rows is rank. Because of this one. Rank equal to number of non-zero rows when the matrix is in echelon form, please. Okay. Next. Now observe the definition. Two matrices A and B are said to be equivalent, not equal, equivalent, not equal. Equal means the corresponding entries are equal. Automatically the order should be same. But equivalent means if one matrix can be obtained from the other, one matrix obtained from the other by a sequence of elementary transformation, maybe row transformation or column transformation. We denote it as A tilde B. A tilde B means A is equivalent to B. You can read it as A is equivalent to B. I'll explain the example. Suppose A is equivalent to B, A is equivalent to B if and only if rank of A equal rank of B. If and only if rank of A is equivalent to B, then ranks are same. If ranks are same, A is equivalent to B. I will explain this definition and this through an example. Now coming to the problems. Find the rank of the following. Okay, the heading is same for all the problems. The first problem. You are asked to rank of this one. From the definition, okay, what is the order of this one? Please tell me first. What is the order of this one?
3.
Very good. What is the largest minor? 3 cross 3. Directly itself. So I want to calculate determinant of it. In fact, I am not using definition. I want to reduce to echelon form, means steps. It is not echelon form because when you start here, you should not go like it. You have to get down 3 steps at a time, L shape. You should get down and then go. But you should get down one step only. So I am getting down only 1 step. Otherwise, it is not echelon. To get down, I should make these 2 are zeros below the step. To make these 2 are zeros, I am using arrow. Using arrow, make 0. Okay. With respect to this one, R2, replace second row with second row minus first row to get 0 here. R2 minus R1. Replace second row minus first row. Now to get 0 here, R3, please tell me R3 minus what? Please, to get 0 here, R3 minus, what do you rate?
2 or 1.
Very good. R3 minus 2 R1. We use that. Replace third row with the third minus 2 times R. Now we apply these 2. Second row changes like it, third row changes like it. But first row remains same. No change in first row. Now we do the calculation. R2 minus R1. 1 minus 1. 4 minus 2. 2 minus 3. Now third row changes like this. 2 minus 2 into 1, which is 0. 6 minus 2 into 2. 6 minus 4, which is 2. 5 minus 2 into 3. 5 minus 6, which is minus 1. Okay. Now I am getting down 1 step. These 2 are 0. Now I want to get down only 1 step. I should not get down another step. If you get down another step, it is not echelon form. Now I want to get it is 0. To make it 0, we use arrow. What is the operation? Please tell me. R3
Minus
to get
R.
0. Minus R2. Can I use R3 minus R1?
No,
Can I
sir.
use R3? Why?
No, sir.
Yes. Why I
Only
should
first
not use
term.
R3? It will be disturbed.
Only values.
Whatever the operation you are selecting, the zeros which we already got should not be disturbed, please. Without disturbing this, you should select the operations always. Hence, R3 minus R2. So, the change is only in third row. First two rows, you just copy and paste first two rows. Now, third row, we did like it 0 minus 0. This also I am doing 0 minus 0, which is 0. 2 minus 2. Minus 1 minus half minus 1 means minus 1 plus 1, which is 0. Okay. Now I am drawing the steps. One step we get down. Now this is 0. We go straight, please. It is 0. Now it is an echelon form. It is echelon form. What is the rank of this one, please? Number of steps means number of non-zero rows. What is the rank of this one, please?
2, sir.
Its rank is 2. But I am asking rank of the given matrix. These two are not equal. Its rank is 2. Its rank is also 2. The reason, let me explain. These are not equal. These two are equivalent. Please, this A and this one. These two are, the first and third matrices here are equivalent. Equivalent means one matrix, you can call it as B. This B is obtained from A by a sequence of transformation, maybe row or column. One matrix obtained from the other by a sequence of transformation. Then those are equivalent. If two matrices are equivalent, definitely their ranks are same. We know the rank of this one, but it is an echelon form. So its rank is 2, automatically its rank is 2. The rank of the middle one, this is also 2 because these three are equivalent to one another. Okay, next. Another problem. Observe this problem. What is the order of this one, please? What is the order?
3 cross 4.
3 cross 4. Very good. What is the rank of this one? Does the rank is 4? Can I take rank is 4?
No,
Rank?
sir.
Why rank is not 4? Immediately you can tell. Because you know the rank definition. I can't get 4 cross 4 from it. Hence rank is not 4. Okay. So I am not using definition because I have to evaluate many determinants. So I try to reduce to echelon form. Means we draw one step. Now I want to get done only one step at a time. So I require these two are zeros. Use arrow to get zeros here. Now to get 0 here, please tell me the operation. R2. Please.
R2 minus 3 R1.
Minus 3 R1.
Now to get 0 here. R3. R3.
Plus 2 R1.
R3 plus 2 R1.
Very good. Okay. The first row remains same. Now second row, we are replacing second row minus 3 times first row. 3 minus 3. 4 minus 6. Please, 3 2s are 6. 4 minus 6. Minus 2. 1 minus 3 into 0 means 1 minus 0. 2 minus 3 into minus 1. 2 plus 3, which is 5. Second row changes like it. Now third row. Minus 2 plus 2. 3 plus 4. 2 plus 0. 5 minus 2. Okay. Now it is not in echelon form. Followed because I am getting one step, later 2 steps. Are you following? Is it echelon form? Is it echelon form?
No,
One step,
sir.
then 2 steps. Now I can tell rank of this one. How can I tell? It is not echelon form, but I can tell the rank, please. How? I got the answer. Just writing this step, I got the answer. Please. Can anyone tell the rank of this one? What is the rank? You have to make it 0, reduce to echelon form, then only you can tell. Without reducing, I can tell the rank. Please observe here, I am not reducing to echelon form further, but I am using rank definition now. I can use rank definition. Don't expect always echelon form. Using rank definition, I am taking third order minor, please. This third order minor. The first three. Use rank definition. If you use these three, the reason is this. C1, C2, C3, when you select, its determinant is, what is the determinant of this one, please tell me? Using first column. What is the determinant? 1 into determinant of this one. AD minus BC. I just observed -4, -7 not equal to 0. That I observed. Simply I observed this. Using first column, take these three. 1 into AD minus BC. -4, -7 not equal to 0. Therefore, I have third order non-vanished minor. Hence its rank is 3. Automatically the given one rank is also 3 because these two are equivalent. I think got it. Okay? The many require the rank definition also. AD minus BC here not equal to 0. Therefore, third order minor not equal to 0. Hence rank is 3. Suppose if you get 0, what you do? We try to get these three minor or reduce to echelon form. Whenever AD minus BC equals 0, it becomes easy to reduce to echelon form like this because AD minus BC here 0. Whenever AD minus BC appears as 0, you can easily make 0. Okay, reduce to echelon form. Not equal to 0 directly gives rank. Next problem. This is a problem given for GATE examination for mechanical in 1999. How do you find rank? Observe it. 3, 2, -9, -6, -4, 8. You are asked rank of this. Observe it. I want to get down. Now tell me the operation. How do you get 0 here? R2. Please tell me. R2
plus 2R1.
plus 2R1. Very good. How do you get 0 here? R3
Plus -4R1.
-4R1.
Very good. I applied those. Now the first row remains same. Second row plus 2 times first row. Observe. I did the calculation. Now third row -4 times first row. I am doing the calculation, please. Okay. Now I want to draw the steps. I have only one step, one non-zero row. What is the rank here? What is the rank? Please tell me the rank. Rank
One,
is
sir.
1, sir.
1, sir.
rank of automatic rank of that is 1. Okay. Now you need not do all this. Please let me explain in another way. Now, after seeing this matrix, you just observe these are nothing but the second row is nothing but -2 times first row. Here I am writing, please. -2R1. The second row is -2 times first row. Similarly, the third row is nothing but 4 times first row. This is my observation. Or divide this with -2, you will get this. Divide this with 4, you will get first row. Follow? You need not do all it. So, the second row and the third row are obtained from first row using scalar multiplication. So the second row depends on first row with -2 times. Third row depends on first row with scalar multiplication 4 times. So rank, another definition. I am giving to you because once it is given in GATE examination, which of the following does not define a rank? Does not define a rank means among the 4 options, 3 are rank definitions. Okay, once if you know the concept, you can easily identify it. Rank is number of linearly, note, observe this, rank is number of linearly independent row or column vectors. Row vector is only one row, column vector is only one column. Number of linearly independent row vectors, it is another definition of rank. In this problem, second row dependent on first row, third row also dependent on first row. So you have only one independent row, hence rank is 1. Number of linearly independent rows, the first row. You have only one row and remaining depends on it. Dependent delete. Think like it. Dependent delete. You remain with this, rank is 1. Okay. Don't think we are removing only second and third. Among these 3, you can remove even first row and third row. First row, third row. You remain with only one row. You can think first row depends on second row. Third row also depends on second row. Think like it also, there is no wrong it. But finally, among 3, only one is independent. Remaining 2 depends. Number of linearly independent row vectors. Next, one more example. Now tell me the rank here. What is the rank? Observe this. A problem given for EC in 2006. Just observe the dependency. Here, this is R1. R3 depends on R1. 1 R1. So this is, you can delete it. Dependent delete. Think like it. Depend delete. You remain with only 2. Now use rank definition. AD minus BC. Second order. Not equal to 0. I have taken these 4. Not equal to 0. Means you have second order non-vanished minor. Hence its rank is 2. Suppose if it is 0, we take these 4. Or if it is a 0, we take these. Okay. Without using echelon form directly, you can come like this. Because it is dependent delete. Next. Now observe this problem. It's a problem given for computer science in 1995. The rank of the following n plus 1 cross n plus 1 matrix, where A is a real number, is 1A, A square, A power n. Now observe 1 means A power 0 you can think. A power 1, 2, n. You have n plus 1 columns, also n plus 1 rows, because it is given n plus 1 cross n plus 1. It is a square matrix of order n plus 1. What is the rank of this one? Anyone please? What is the rank? Can anyone tell rank of this?
1.
Rank is 1. Very good. Because?
Independence. Other dependents are avani.
Right. Very good. Very good. It is R1 only. Delete. Dependent delete. Dependent delete. You remain with only one row. It is independent. That's why rank is 1. It seems to be a very big problem, but once if you know the definition, it becomes very easy. Dependent delete. Next. The next problem. Given for electrical in 2019, because the syllabus is common for all. What is the rank of this matrix, please? Observe all are zeros here. Remaining are ones. To reduce to echelon form, I should not get down. It should be non-zero. I have to interchange and then make 0. Can anyone answer this problem? How to proceed? Do you reduce to echelon form? To reduce to echelon form, it should not be 0. Therefore, interchange first R12 and then make zeros. You can do like it. If you observe, we do one thing. Use rank definition directly. Why should we use always echelon form? What is the largest order minor here from M? Can I get 4 cross 4? Can I get 4 cross 4 from this? Please.
No, sir.
4 cross 4. How can I get? I can't possible. 3 cross 3? I can. The 3 cross 3 minor means it's a determinant. I should calculate. Get up. Because third order minor means itself. Itself also I have to calculate. Third order. I have 3 cross 3. Itself is submatrix. So datum. Datum directly you can use definition. Using any row or column. For example, I use the first row. With a different column. 0 into, I need not write. Therefore, minus 1 into AD. 1 into 0, minus 1 into. I am using first row to calculate this one. Minus 1 plus, minus plus. Minus 1 into AD. 1 into 0, minus 1 into 1. Next, plus minus plus 1 into what? 1 minus 0. I simply calculate the determinant using first row. Now this is not equal to 0. What is the rank? Now tell me. What is the rank?
2, sir.
Rank is
2.
not
3,
2.
sir.
3, sir.
Order is 3. We use rank definition. I have third order non-vanished minor. Third order non-vanished minor. Therefore, rank is 3. I think you observed. Don't go to always echelon form. Using rank definition, you can easily calculate it. And if it is 0, suppose if it is 0, what is the rank? If it is 0, we try to identify second order minor. If it is not, if at least one second order minor not equal to 0, rank is 2. If all second order minors are 0, rank is 1. Okay? We come from highest to lowest like this. Next. I think you follow the importance of rank definition. There is no dependency to remove here. Next one. Rank of A 1 to 16. How do you find rank of this one? Please. How do you find rank of this one? Do you make these 3 are zeros with respect to this? Echelon form? Not required because the increment remains a 1, 2, 5, 6, 9, 6. We do one thing. I want to reduce the entries first using columns or rows. You can use rows or columns. C2 minus C1. C3 minus C1 only. To avoid confusion, use only C1. C4 minus C. Where the increment remains same. The first row column remains same. Column wise rate, please, because using column operation. Second column changes as second minus first column. 1, 1. That's why I used this one. Now C3 minus C1. Now C4 minus C1. I need rank of this at least. Ranks of this and this are same. What we do now? Please tell me. Dependent can delete. Dependent can delete. Now this is nothing but 2 times C2 second column. It depends on second column. He can delete it. Similarly, it depends on C2. 3C2. This also can delete. Now finally you remain with this only, please. Now I can use rank definition now. I can't get fourth order. Are you following? How can I get fourth order? I already deleted these two. Dependent, delete. I can't get fourth order. I can't get third order also. Now I can get second order. I can get second order. Using rank definition, I am taking these 4. 1, 1, 5, 1. Here AD must be not equal to 0. I have second order non-vanished minor. What is the rank of this one, please?
4,
What is the
sir.
rank? Rank is 2. Hence, rank of the given matrix is also 2 because these two are equivalent. I think you realized. Not only echelon form, dependent, delete, then rank definition. Okay. Next. Problem given for civil engineering. Now observe this and tell me the rank. How to proceed first? Don't expect always echelon form. What we do by observing this? First, try to remove the dependencies. Please. Did you identify any dependencies in it? Dependency on that.
First column is dependent on second column.
Yes, sir.
First depends on second or second depends on first. Okay. Now this is 2C2. Delete it. You remain with third. So now what we do? We take determinant of this one. If determinant is not equal to 0, rank is 3. If det is 0, not equal to 0, rank is 3. If it is 0, we take second order. You can proceed like it. Okay. Or I observe directly, I can tell the rank without calculating determinant also. I'm using one more technique here. Dependency means don't think only scalar multiple. Ax plus by also dependence. Ax plus b. If you observe 2 plus 1, 3. 3 plus 4, 7. 1 plus 0, 1. Therefore, this last column depends on second and third column. Nothing but C2 plus C3. This depends on these two. Using these two, you are getting this. Just like Ax plus by time. K C2 plus L C3. K value 1, L value. Depend. This also depends. 2 plus 1, 3 plus 4, 1 plus 0. Dependent, delete. Dependency, don't think just only scalar multiple. Scalar multiples, addition also. Maybe 2C2 minus 5C3 also. But it becomes difficult to observe that. But just addition you can easily observe, or subtraction also you can observe. Or another way of thinking, 3 minus 1, 2. 7 minus 4, 3. 1 minus 0, 1. Therefore, the second column depends on third and 4. He can delete this also instead of these. Among these three, one depends upon the remaining two. So I deleted one. He remain with this. Therefore, rank cannot be 3. It may be 2. Therefore, using rank definition, take these 4 or these 4, no problem, not equal. AD minus BC not equal to 4. Hence, what is the rank? Please tell me the rank.
2, sir.
2, sir.
2, sir.
2. Its order is 2, hence rank is 2. If you are unable to observe, take the determinant. Determinant definitely 0 you will get. So we come to second order. Okay. If you are unable to observe. Next. Problem given for EC in 2017. What is the rank of the matrix? Please tell me this. First, observe always dependencies. Dependency means not only scalar multiples, addition, subtraction of any two. First, observe and tell me. Any dependencies in it?
First column
You are
on
able to
second
observe
column
first column.
and second.
No, you are not getting scared. It is 0, please. It is 0. 2 5s 10, 2 1s 2, but 2 is not there.
First column,
2
third
3s are.
column.
First column,
Third column.
third column, very good. 2 5s 10, 2 1s are 2, 2 3s are. Therefore, I can delete third column. Another way of doing, okay, you are telling, you are right. I am doing in another way. I want to reduce the entries also 1 by 5 times. Another way of doing the problem 1 by 3 times. This is the problem is same as this one. Please observe. I reduce the entries 1 by 5, 1 by 3. If you are able to observe first and third, okay. Or another way of doing, first reduce the entries. Use row or column away, entire row divisible by 5, entire row divisible by 3. You are convert. Now you can easily observe, please. After reducing the entries, you can easily observe the first and the third column. Now it depends, you can delete. Here, determinant is 0 minus 2 not equal to 0. You have second order non-vanished minor. It depends, delete. I think got it? Okay. If you are able to observe directly, okay. Reduce the entries, then observe. Okay. Next. Problem given for civil engineering in 2015. Observe the problem, how it is given. The problem not given explicitly, the problem given in notation. A equal to Aij, please it is. Here Aij given, here also Aij, small error, the printing mistake. Aij. I and J lie between 1 and n. With n greater than or equal to 3. This n is 3 or above. Aij equal I into J. Entries I into J. What is the rank of A? The problem given in notation. Whenever problem given in notation, it becomes easy with examples. So to answer this question, the entries are I into J. Means I stands for row, J stands for column. So each entry obtained from its place, ith row into jth column. The entries obtained from ith row and jth column. So for your clarity, I am taking n equal to 3, I will check it. So observe it.
The rank is 1, sir.
Rank is 1, okay. How can you? How can you please?
Sir, as sir, first element అంటే A11 కదా సార్.
Right.
A11 అంటే అక్కడ I into J ఉంది కాబట్టి 1 into 1 అంటే ఫస్ట్ ఎలిమెంట్ 1 వచ్చింది సార్.
Right, very good.
Similarly, second element 2, 3, and second row 2, 4, 6, and third row is 3, 6, 9, sir.
Second row element 2.
4, 6.
Very good, very good, very good.
And 3,
Right,
6,
right.
9, sir.
Right, very good, very good, very good. Right, you observed it very good. Now observe. Okay, for your clarity, I am showing this one. I stands for row right here. First row, second row, third row. J stands for column. First column, second column, third column. This first row, second row, third row. It is first column, second column, third column. Now the entries, you explain me. That only I am writing. 1 into 1, 1 into 2, 1 into 3. I into J. Okay. 2 into 1, 2 into 2, 2 into 3. Whatever you expect, I am writing here. I am showing. 2 1s are 2, 2 2s are 4, 2 3s are. Because I into J. Third row, 3 1s, 3 2s, 3 3s. Okay. Now, your matrix is red colored. I require rank of this one. The second row, 2R 1. Third row, 3R. Delete. Third row, 3R1. Delete. Like this, you can delete remaining. You remain with only one row. Hence, rank is 1. Your approach is very nice. Okay. I explained visually, of course. You thought directly in your brain. I explained visually. Okay. Right. What's your name, please?
Sir, Nitin, sir.
Please.
Nitin.
Nikir, very good, very good. Nice observation. Next. Now observe this. For any real matrix of order m cross n, rank of A equal rank of A transpose. We know rank definition. It depends on determinants. Therefore, A and A transpose need not equal. When it is symmetric, they are equal. But their ranks remain same. Their determinants are same, their ranks are also same. Now observe one more. Rank of A into A transpose also remains same. What is the order of A into A transpose? Please tell me. If A is of order m cross n. What is the order of A into A transpose? Order of A into A transpose. Order I am asking.
M class and sir.
M?
M cross N.
M cross M only, because M cross N, then N cross M, transpose, M cross M. It is same as rank of A transpose A also. What is the order of A transpose A? Order. What is the order of A transpose and then A? Order I am asking. What is the
N
order?
cross N.
M cross M, because N cross M, then M cross M. N cross. Its order is M, its order is N. But the ranks are same, please observe. Rank of A transpose, A into A transpose or A transpose A. Please remember this. You can observe with examples also. Next. A problem given for Tribri in 2016 based on this. Let A be a 4 cross 3 real matrix with rank 2. Matrix not given, order given, also rank also given. Which one of the following statement is true? Okay. You are asked rank of A transpose into A. What is the answer? Anyone, please? Just observe and tell me the answer.
B, sir.
Option?
B.
Why it is B?
Rank of A is equal to rank of A transpose into A.
Very good, very good. Direct definition. A transpose A. Rank is same as rank of A. What is rank of A? 2. Give to us. Rank of A is 2. Automatic rank of A transpose A also 2. Equal to 2 because of this one, please. Okay. Direct observation. Direct which it is. Once if you know this one. Okay. Next. The next problem. The highest possible rank of order 4 cross 6 is. Please tell me the answer.
4, sir.
4. Very good. How do you know it? How do you know it?
4 cross 4.
You know rank definition. That's why you are able to answer this, please. Okay. If you don't know rank definition, if you know just the echelon form, you can't answer it. Answer is 4. I can't get 5 cross 5. I can get 4 cross 4, 3 cross 3. Highest possible is 4. Okay. Now, instead of giving this, many teachers give this to you as a formula. I don't want to convince you as a formula it is. You require the concept. The concept is very, very important to you. What is the maximum possible rank of order M cross N is minimum of M comma N. Okay, when I ask this bit, many students tell me this formula. It is a formula, sir. Minimum of M comma N, sir. I don't believe such for students because you should know the definition. First of all, definition is important. I think you realize the importance of definition in bits also. I have not reduced echelon form. Certain times echelon form, certain times using rank definition, certain times I try to reduce echelon form, then I apply rank definition. Certain times dependencies, number of linearly independent. Okay. Next. Rank of A plus B less than or equal to rank A plus rank B. Just like triangle inequality. That you can easily observe. Rank of A plus B less than or equal to rank A plus rank B. Of course, whenever you are talking A plus B, A and B should be of same order. The next one. Rank of A minus B greater than or equal to rank A minus rank B. Minus B. Because you are subtracting is definitely small value compared to it. You are adding, it's a bigger value. Adding numbers. Here subtracting number, that's a smaller number. Next. Rank of AB, it is not rank A into rank B, which is wrong, please. Det of AB is det A into det B, right? But rank of AB less than or equal to minimum of the rank of A, rank, comma, rank of B, please. It's not rank A into rank B, which is wrong. Rank of AB is smaller than minimum of rank of A, comma, rank of, or equal sometimes. Less than minimum of separate ranks, please. The next. Okay, problem. What is the rank of singular matrix of order n? Please tell me the answer. What is the rank of singular matrix of order n?
0, sir.
Less than or equal to n minus 1.
Very good, very good. Less than or equal to n minus 1 is the correct answer. Okay, you told me 0. I am not asking singular matrix definition. I am asking its rank. A matrix is said to be singular if its determinant is 0. Order n means n cross n. N cross n square matrix. From rank definition, the maximum possible minor, the largest minor is itself. Its determinant is 0 because singular matrix is determinant is 0. Therefore, itself minor vanished. Therefore, rank is not n. I can't get n plus 1. I can't get n plus 2. I can get n cross n, but it vanished from rank definition. It is not rank n also. So I should come down. Then rank is, don't say n minus 1. Sometimes it may be n minus 2, n minus 3, we don't know it. So the answer is n minus 1 or fewer. Less than or equal to n minus 1 is correct. Here you require what is singular matrix and the definition of rank also. Definitely it is not n. Less than or equal to n minus 1. Okay, next. Now observe this. A problem given like this, please. Given for electrical in 2008. If the rank of a 5 cross 6 matrix Q is 4, of the 4, 5, 6 answers given. Order is 5 cross 6, 5 rows, 6 columns, but rank is 4. Then, which one of the following statement is correct? Please answer it by reading it. Anyone, please? I have already explained all the definitions of rank. What's the answer?
Yes, sir.
Yeah, very good. Because rank is number of linearly independent row or column vectors. Therefore, you have 4 linearly independent rows because rank is 4. Also, you have 4 linearly independent columns, not 5. If you have 5 independent columns, definitely rank is 5. Automatically, you have number of 5 independent vectors also. Right. Number of linearly independent rows, 4 rows and 4. Okay. You know the rank definition, another definition. That's why you are able to answer. Next. Now observe this problem. The problem given in notations. Q1, Q2 and so on, Qm are n-dimensional vectors. These are vectors. Each is not number, vectors. Means row vectors or column vectors. With m less than n. M less than, this is m less than n. This set of vectors is linearly dependent, given that these are dependent. Q is a matrix with Q1, Q2, Qm as the columns. These are the column vectors, please. Q is a matrix. What is the rank of this Q? You are asked. This Q indirectly given like this. Q contains these columns. Here Q1 is a column, Q2 is a column, Qm is a column. Okay, observe it. Now the 4 options given like this. First we write Q. To answer this question, we try to write Q first. Your Q is this one, please. Q1, Q2, and so on, Qm. But it is not row vector, please. Because each Q1, Q2, Qm are columns. The first column denoted with Q1, column vector it is, n-dimensional vector. Q2, column vector. Qm, column vector. What is the dimension of Q1? Q1 means it is a column vector. In that column, how many rows are there? In that column, how many rows are there? Observe it, n-dimensional vector. That means this Q1 contains n numbers. Q1 contains n numbers. For example, A11, A21, ANM. A11, A21, AN1. This Q1 contains these n numbers. These n numbers. N rows you have. Because Q1 is n-dimensional vector. Similarly, Q2, again n-dimensional vector. You can write Q2, n-dimensional vector. N numbers. And so on. Qm, n-dimensional vector. Qnm you will get. Okay? These are the columns. Now this is your Q. This is your Q. Please, I finished this. What you are asked, what is the rank of this one? What is the rank of this one? It is, the order is, you have how many rows in it? Please tell me. How many rows? Number of rows in it?
N.
Number of columns?
M.
Therefore,
M.
its order is n cross n. N cross n. Of course, rank of Q is same as rank of Q transpose. Okay. Therefore, given to you m less than n. M less than n. What is the maximum possible rank of Q? Because m less than n given to you. What is the
M,
maximum
sir.
possible rank?
M.
Maximum possible rank is
M.
m. Maximum possible rank is m. What you are given? This set of vectors is linearly dependent. If rank is m, you should have m linearly independent vectors, please. If rank is m, rank cannot be n. Clearly, rank cannot be n. The maximum possible rank is m. Suppose rank is m, your answer is m. You should have m linearly independent vectors. But given to you the set of vectors, this set of vectors are linearly dependent. So rank is not m. If rank is m, you should have m independent vectors. At least one vector depends on remaining. Means one vector you can delete it. Hence rank is, now tell me rank. What is the answer? Please tell me the answer. Because set of vector linearly dependent given, dependent delete. Maximum possible is m. All these m are not independent. One, because dependent given. Dependent delete. Then what is the rank? Please.
Less than m.
Less than m. Because rank cannot be m. Because dependent given, dependent delete, it should be less than m. The answer is. I think you follow. Okay. Next. Not between m and n. And m. Next problem. The problem given for civil engineering. X equal x1, x2, and so on, xn transpose is an n-tuple non-zero vector. The n cross n matrix V equal x into x transpose. Capital X is transpose of this one. This means capital X is a column vector, please. Transpose given. Capital X is column vector. X transpose is this row vector. This transpose of transpose is itself. This X given X is row transpose is column vector. X is column vector. X transpose is row vector. Now observe. Your four answers given. this X has rank 0, rank 1 is orthogonal has rank.
Rank 1, sir.
Rank 1. How? How rank 1?
సార్ ఇక్కడ ఫస్ట్ ఎక్స్ తీసుకుంటేమో ఇక్కడ ఎన్ కాలమ్స్ ఉన్నాయి సార్. నెక్స్ట్ దాంట్లో ఎక్స్ ట్రాన్స్పోజ్ అంటే అప్పుడు ఓన్లీ ఒక కాలం వచ్చింది కానీ ఎన్ని రోస్ వస్తాయి సార్. మనకి అక్కడ ఫస్ట్ దీన్ని తీసుకుంటే 1 cross n ఉంటుంది సార్ మొత్తం.
What you are telling, I am showing for other students also, for the purpose of other students. Okay. Now your X is just a column because it's transpose. I am writing just 3, n equal 3. For your clarity, I am not taking n cross n equal 3. Okay. N equal 3. Now what is X transpose? Row vector. X is whole transpose. Okay. Followed. Now what is the order of this one? 3 cross 1. Its order is 1 cross 3. But you are telling 1 cross 1, it's not 1 cross 1, please. You explain me 1 cross 1, but it is 3 cross 3, please. You're following? X is transpose of this one means row transpose is column vector. And its transpose is row vector. It is 3 cross 3, please. You will get this, please. First row with first column, x1 into x1, x1 square. First row with the second column, x1, x2. First row with the third column, x1, x3. Okay? With the first row with the different columns. Now second row with the first column. Second row with the second column, x2 square. Second row with the third column. Now third row with the first column, third row with the second column, third row with the third column. This is your given matrix. Instead of n cross n, I have taken n value 3. Now what you are asked, rank of this one, please. How to find rank of this one? Are you following? Just observe it. If you observe, use rank definition. Here AD minus BC is 0, very clear. Observe it. AD minus BC is clearly 0. Here also AD minus BC is 0. Here also AD minus BC is 0. AD minus BC is 0. Now I am showing those to you for your sake. Close this. Remaining AD minus BC is 0, very clear. Second order minus x1 square, x2 square minus product of this one is x1 square minus x2. It is 0. I don't have second order minor. Look, I do one thing. I am closing this and this. Now AD minus BC. x1 square, x2, x3. Minus of product of this x1 square, x2, x3. By symmetry you can observe. It is also 0. Now I do one thing. I am taking the 4 corners. AD minus x1 square, x3 square minus product of these. That is also 0. Means all second order minors vanish. When all second order minors vanish, automatically third order minor vanish. Third order minor also vanish because third order minor we express in terms of second order minors. All second order minors vanish. Automatically remain with first order as rank 1. Why it is not 0? Because non-zero vector. Non-zero vector means at least one entry not equal to 0. When at least one entry not equal to 0, automatically at least one of these 9 not equal to 0. When I take n equal to 3. That's why rank is 1, not 0. I think you follow. Any doubt? It is just an observation. Okay? All second order minors vanish. Automatically third order minor vanish. You remain first order and non-zero given. At least one entry non-zero. Automatically at least one entry non-zero as rank 1. Okay. Next problem. If x equal to x1, x2, xn is an n-tuple non-zero vector, the same problem I have given in reverse order. X into x transpose. The row vector. Okay. Now, a similar model
Rank
is
is n, sir.
here. Now I agree with you. Okay. Now I agree with you. You thought like this previously. Okay. Now here, non-zero vector, automatically this number definitely non-zero because sum of squares, because at least one entry non-equal to 0, sum of squares definitely not equal to 0. Hence, it is 1 cross 1. Hence, rank is 1. I think you observed x transpose x, x transpose. Both ranks are 1, even though the orders differs. Okay. Next. The next problem. Not the next problem. These are the concepts. Suppose rank of A is n cross n matrix. Then rank of adjoint of this matrix is also n, please. If rank of A is n, order n, the rank of adjoint A is also n. Next. Suppose rank of this is n minus 1, then its adjoint rank is 1, not n minus 1, please. When it is n, adjoint rank is n. When the rank is n minus 1, means its determinant is definitely 0. Then rank of its adjoint is 1 only. Next. If rank is n minus 2 or fewer, then rank of adjoint is 0. If rank is n minus 2 or n minus 3 or n minus 4, its rank is 0. I'll explain why these three also. Okay. If you remember, okay. I'll explain the concept part also to you. Rank of A, when you know, you can tell rank of its adjoint. When it remains same, it gets same. When it reduced 1, it is 1. When it reduced more than 1, it is 0. I'll explain to you. First one I want to explain to you. Suppose rank of nth order matrix is n, then rank of adjoint A, what is the answer, please? What is the answer? I have already given. What is rank of adjoint A?
N, sir.
Please? Yeah. Okay, you know the formula. Okay. Let me explain this to you. The answer is n. I know A into adjoint A is because I require a relation between A and adjoint A. A into adjoint A is adjoint A into A is det A into n, because A inverse is adjoint A by det A. This I know it. Rank deals with the determinants, because determinant of submatrices. So I want to explain, for your clarity, I am taking A equal to third order. Adjoint A is transpose of cofactors matrix. A into adjoint. This is same as adjoint A into A, of course. I am writing directly det A into In. Det A into I3 here. All the entries of I multiply with det A. It looks like this, please. Now, observe is applying determinant. Determinant of the product is determinant of this product is determinant of this one. Determinant of this one is det A whole cube. Here det A power n when you are taking nth order. Did you follow this? Determinant of the product is determinant of this one. Determinant of this one is from first row take det A common, second row take det A common, third row take det A common, det A whole cube into unit matrix. Unit matrix determinant is 1. So det A whole cube. Suppose if it is nth order, det A whole power n. Okay, follow this step. Determinant of A into adjoint A is det A power n you will get. Now, det AB is det A into det B. So this can be written as det A into determinant of adjoint A, the left side. Therefore, determinant of adjoint A is det A power n minus 1. Already explained this to you previously also. Det A power n minus 1 because det A is a number. Now observe, suppose rank of A is n. From rank definition, the determinant of A not equal to 0. If the determinant is 0, because n cross n, if the determinant is 0, rank definitely not n from rank definition. Okay. So, when it is given, when rank is n, determinant definitely not equal to 0. Det A not equal to 0. When det A not equal to 0, automatically det A power n minus 1 also not equal to 0. Hence, determinant of adjoint A also not equal to 0. When determinant is not equal to 0, its rank is its order. Again, it is n cross n matrix. That's why rank is n. Rank is n. The order of adjoint A is also n. That's why rank is n. Okay? Because det A not equal to 0, automatically this is not equal to 0 from rank definition. The next one. Suppose the rank of A is n minus 2. N minus 1 I will explain later, please. Rank of A is n minus 2 or fewer, of course. I have taken n minus 2. Then rank of adjoint A. What is the answer, please? What is the answer? I have already given as a formula.
0.
0, very good. Why it is 0? Let me explain. Once if you know the concept, you never forget. Suppose I have taken a general matrix. I am not using A into adjoint A because det A is 0 here, please. Det A is 0. Because n minus 2 means definitely det A is 0. Now adjoint A is transpose of cofactors matrix. I am explaining by taking n value 3. Now observe this. Because determinant of this one is not n. Also not n minus 1. Automatically, suppose it is n value 3, 3 minus 2, which is 1. Rank is 1 now here. Rank 1 means automatically all second order minus vanish. Second order minus also vanish. Otherwise, rank is n minus 1. So, observe this. C11 is this one. But this C11 is 0 because Cij is n minus 1th order minor. Because rank is n minus 2 means higher order minor should vanish. You have at least one non-vanished minor of order n minus 2. From rank definition, you have at least one non-vanished minor of order n minus 2. And all minors of order above n minus 2 vanished. Above n minus 2 means n minus 1. N minus 2 plus 1. N minus 1. This vanished. This vanished. So, all these entries become zeros. Therefore, adjoint A is nothing but 0 matrix now. Because all these are zeros. So, rank of 0 matrix is 0. It is a reason. I think follow. All n minus 1th minors become 0. So, these are entries, all are 0, that is 0 matrix. Or in other words, when rank of A is n minus 2 here, then adjoint A is a 0 matrix, please. Next. Now, and rank is n minus 1. What is rank of adjoint A? Please tell me. I have given as a formula. What is the rank? Please.
1, sir.
Very good. Okay, it is a bit complicated to explain you. I'm explaining using induction process, of course. Suppose rank of A is 0, then A should be 0 matrix. Then adjoint A is also 0. Implies rank of adjoint A is also 0. Suppose rank of A is 1, then your A contains, please observe, I am taking 2 cross 2 now. A, B, AX, BX. It depends. Depends. Because rank of A is 1. So the second row depends. Second row or second column. I am taking like this. Your A should be like it. When rank is 1, your A should be like it. Then I require its adjoint. Adjoint, you know how to write adjoint? Interchanging these two positions and minus of these two. Interchanging these two. And these two are minus signs. You know how to find A inverse. Adjoint A by that A. That adjoint A is when 2 cross 2, interchange these two and put minus signs here. It is adjoint A. Now rank of A is 1. Automatically here implies rank of adjoint A is also 1. Because this depends on it, please. This depends on it. You just multiply with minus x. Minus x times this. Minus x times this. Dependent delete. You remain with one column, its rank is 1. Here dependent. Dependent, that's why rank is 1. Whatever its adjoint also, rank 1. Dependent. Next. Suppose rank of A is 2. I am taking third order now. I have 2 linearly independent row vectors. A, B, C, P, Q are linearly independent. This third one should depend on it. AX plus BY. General form I am taking. BX plus QY. CX plus RY. Please observe. Multiply the first row with X. Multiply the second row with Y. And then add. You are getting third row. Multiply first row with X. Second row with Y, add it, you are getting third row. Means third row depends on first and second row. Third row dependent, delete. Hence rank is 2. That's why I have taken general form. Now I need adjoint of this one, which rank is 2. Now observe, adjoint. You know how to write adjoint. Third order. All second order minus. To write adjoint, please. The first entry, product of this minus product of this. Product of this minus product of this. QCX plus QRY minus of PXR minus QRY. QRY get cancelled. You will get this, please. Taking X common. QC, because QRY cancels. QC minus BR. QC or CQ. QC or CQ. CQ minus BR into X. This is your C11. Now C12. C12 is product of this minus product of this. PCX, PRY get cancelled. You will get PCR CP minus AR into X. That is C12. But adjoint is transpose of cofactors. Therefore, the C12 right here as a column. C12. Because transpose. Actually C12 cofactor matrix, but its transpose is adjoint. AD minus BC type. Similarly, the next one, C13. PBX, PQI. PQI get cancelled. You remain with the BP minus QA into X. That is C13 right here as the first column. Okay, like this. Next. Now observe this. C21 right here. This product of this minus product of this. Okay, you can do the calculation part. Now C22 right here, product of this minus product of this. Similarly, C23. Now, third row. This product BR minus CQ here. BR minus CQ. BR minus CQ or CQ minus BR, I have written minus of course. Next, please. Because cofactors, please, with signs also, not only minus, please, with signs. With signs also I have written. Minus 1 for I plus j also I am writing. I calculate all these, please. This is your adjoint here. Now, if you observe CQ minus BR, CQ minus BR, CQ minus BR. Here AR minus PC, AR minus PC, here BQ. Therefore, this first column is multiple of the third column. Second column also multiple of third column. Therefore, the first two columns depends on third column. Therefore, the first two columns can delete it. You remain with only one column, hence its rank is 1. First two columns depends on third column. That's why its rank is 1. Now, if you observe, when rank of A is 2, its adjoint is 1. When rank is 1, its adjoint is 1. Please. Now, from this, we can conclude rank of adjoint A is always 1. When rank of A is 1, adjoint A is 1. When rank of A is 2, adjoint A is again 1. Therefore, but for n greater than 1, because it fails for n equal to 1. For n equal to 1, it fails. It's 2, it's 3. Hence, it is always 1. It won't depend upon. When rank of A is n, it is always 1. Of course, please remember it. Instead of doing all this. Okay, one more problem. A is M cross n full rank matrix with M greater than n. And I is an identity matrix. Let A plus denote A transpose A whole inverse into A transpose. Then which one of the following statement is false? A problem given for electrical engineering. You have to check all the 4 options by replacing A plus with this, please. Full rank means, here full rank means the maximum number of rows. You have n independent vectors in it. Full rank, m greater than n, n is smaller here, its rank is n, its meaning is full rank. Maximum possible number of independent vectors, n. So, to check it, observe it, A transpose A is, you can easily observe A transpose n cross m. N cross n. It starts with n cross n mat. N cross n, then m cross n, and invertible. Why it is invertible? Because you have n linearly independent vectors, full rank. N linearly independent vectors means definitely it is invertible. That's why here are given A transpose A whole inverse. This inverse exists. Now coming to the first option, we just replace A plus with this, the given one. I replace A plus with the red color, please. I am calculating the left side. Now, because of associative property, you can easily observe this is A into I. You can easily observe this one. That is A. Because it's AB whole inverse is, please observe how I am getting. This is A. You can think it as B. B inverse into B, please. A transpose A, you can think as B. B inverse into B. This is this A as it is. B inverse into B is I. Therefore, AI is A. Therefore, the first one is right. False. Which of the following is false? You are asked. It is right. Not answer, please. False, you are asked. The second one. AA plus whole square means AA plus into AA plus. AA plus into AA plus. Twice. Now replace A plus with the given thing. A plus replace with the given thing. A, please observe what I did is without substituting, I applied associated property, please. Applied associated property, A plus A into A plus. Now, here using the first one, this A plus A is nothing but A, using the first one. I applied this. This is A into A plus. A into A, which is also right. Using the first one, please. Here I used up. Next, the third one, A plus into A. A plus is nothing but this into A. Because it looks as B inverse into B. B inverse into B is I only. Finally, remain with this. It is your answer. Which of the following is false? You are asked. Okay, with that, the rank part over. Okay, in my next session, I'll explain the next topic. Okay, I finished the rank topic today. If you have any doubts, you can ask, please. It's already read. If you have any doubts, you can ask, please. I started with the basic concept of rank. Later, I explained simple problems, also critical problems. Okay. If you have any doubts, you can ask, please. Any doubts? Any one of you, please?
No doubt.
Yes, sir.
Right. Okay, madam.
Okay, sir. Okay, thank you, sir.
Okay. Thank you, madam.
Thank you, sir.
Alexa, present. Okay.
Sir?
Shall I leave?
Okay, sir. You can leave, sir.
Okay. Thank you, madam.
Okay, thank you, sir. Students, you can leave, ma.